Hey guys, welcome to another video. Now, I'm sure I've said that the quick revision series is done. This video is going to be a correction for a previous video for differential equations. There were two minor mistakes in that video, so I decided to make a new video to redo this question properly. And we're going to do one extra question at the end of the video for finding position functions from acceleration functions. So consider dy over dx is equal to 3 minus 2y. It's a differential equation. Let y equals f of x be the particular solution for this differential equation with f of 2 equals to 1. When they tell me that f of 2 is equal to 1, they are basically telling me that x is equal to 2 and y is equal to 1 as given values at that given point. So in the first question, they said, write the equation of the tangent to f of x at x is equal to 2. Use the equation to approximate f of 2.6. Now, you need to remember in Unit 5 that to find the equation of the tangent, we used to do y minus y of a at that point equals y prime of a x minus a. Now, to translate it in differential equation terms, y minus, what is y of a? It's basically the y that we have over here, which is 1, equals. What is y prime of a? In differential equations, this means dy over dx at the point 2, 1. And then x minus the x that we have over here, 2. So basically, we're going to continue this equation. Now, what does dy over dx at 2, 1 mean? It means we're going to use this equation, but instead of the y, we're going to replace it with the y that we have as given. So it's going to be 3 minus 2 times 1, x minus 2. So it's going to be y minus 1 equals, now 3 minus 2 is going to be 1 into x minus 2. So y equals x minus 2 plus 1, which gives us y equals x minus 1. So this is the equation of the tangent. And now they said, use this equation to approximate f of 2.6. So basically, we want to find y when x is equal to 2.6. So when x equals 2.6, then y is equal to 2.6 minus 1, which will be 1.6. So this is it for the first part of the question. In the second part of the question, they asked me to find d squared y over dx squared, and they wanted me to determine if it's concave up or concave down. Now, if d squared y over dx squared is positive, it's going to be concave up. If d squared y over dx squared is negative, that means it's concave down. And now, what is d squared y over dx squared? It's basically the derivative of dy over dx. So, since dy over dx is basically 3 minus 2y, then d squared y over dx squared is going to be the derivative of this expression over here. So the derivative of 3 is going to be 0. And the derivative of minus 2y, it's going to be minus 2 y prime, which is dy over dx in differential equation terms. So it's usually an implicit differentiation back in Unit 4. We used to derive y and we used to put y prime. But since we're talking about differential equations over here, y prime in this case will become dy over dx. So what is dy over dx again? It's basically this equation. So it's going to be minus 2 into 3 minus 2y. So minus 2 times 3 is going to be minus 6. Minus 2 times minus 2y is going to be plus 2y, plus 4y, sorry. Now, so we need to find it at that specific point, right? So so basically determine the function of it at x equals 2. So at x is equal to 2, the y is basically equal to 1, right? So instead of the y, we're going to replace it with 1. So x equals 2 y equals 1. But there's no x over here, so there's no significance for the x. However, y is there, so we're going to replace it with 1. Minus 6 plus 4 times 1, which is going to be minus 2. And minus 2 is negative. That means it's going to be concave down. Now, part C, the longest part, they said solve the differential equation, give your answer in the form of y equals f of x. So, since I have dy over dx equals 3 minus 2y, I'm going to switch the positions of 3 minus 2y and dx. So, I will have dy over 3 minus 2y equals dx. So, I'm going to integrate both sides. So the integration for dy over 3 minus 2y and the integration of dx. So the integration of dx is going to be fairly simple. It's going to be x plus c. Now the integration for dy over 3 minus 2y, this is the part that is going to cause a little bit of confusion. Hopefully not though. It's going to be integration with substitution over here. So we're going to say let u be equals to 3 minus 2y, and du is the derivative of 3 minus 2y, which is going to be minus 2 dy. Now, a lot of students, they ask me the same exact questions. They tell me, Mr. When you were finding the derivative on the top, you put, instead of the y, you put dy over dx. However, in the integration, you just put dy. The answer to that question is within the question. The derivative of a differential equation should be in the form of dy over dx. But over here, we're not dealing anymore with the differential equation. We're dealing with integration. And in integration, the derivative of y becomes dy. So, in order for me to continue, I compare. I have dy over here. However, over here, I have minus 2 dy. So in order to fix that, I'm going to eliminate the minus 2. So divided by minus 2, divided by minus 2. So du over minus 2 equals dy. And now I'm going to get into the substitution phase. So instead of dy, I'm going to replace it with minus du over 2 over u. Now there's an invisible minus 1 over 2 that you can take outside. And then inside it's going to be du over u, which is going to be minus half ln u. Now we replace u back to its original form, which is 3 minus 2y. So minus half ln 3 minus 2y. That's the integration. You don't add the plus c over here because it would be redundant if you add plus c on both sides. Then they will cancel each other out, right? So you only add a plus c to the one that has dx always. So it's going to be minus half ln 3 minus 2y. Now they wanted us to give the answer in terms of y is equal to f of x, and we also want to find c. So I know that x is equal to 2 and y is equal to 1. So I'm going to replace them. Negative half ln 3 minus 2 times 1 equals 2 plus c. Now, negative half ln 3 minus 2, if you put it on a calculator, it's going to be 0. 2 plus c. Therefore, c is going to be equal to negative 2. So now I need to fix my equation. So I'm going to rewrite what I wrote over here, but instead of c, I'm going to change it to minus 2. So minus half ln 3 minus 2y equals x minus 2. Now, I'm going to switch this with this. So then I will have minus x plus 2 equals half ln 3 minus 2y. Now, in order for me to remove the the half over here, I'm going to multiply both sides by 2. Both sides by 2. So this is going to be minus 2x plus 4, and this is going to be 2 and 2 are going to cross each other out, so it's going to be ln 3 minus 2y. Now, in order for me to eliminate the ln, I'm going to put everything under the power of e. So it's going to be e to the power of minus 2x plus 4 equals 3 minus 2y. So now after you rearrange the equation, 2y is going to be from this side equals 3 minus e to the power of minus 2x plus 4. Divide both sides by 2 and you're done. And this is your y equals half of x. Now the final question, they said find the limit as x tends to negative infinity f of x and limit as x tends to positive infinity f of x. So of course you're going to use the equation that you acquired over here in part C, right? So this is the equation that we're going to use. So limit as x is going to negative infinity, e to the power of minus 2 minus infinity plus 4, right? Oh, we have a 3 behind it, over 2. So now over here, minus 2 times minus infinity will be plus infinity. So 3 minus e to the power of plus infinity over 2. Obviously, I neglected the plus 4 because plus infinity plus 4 is going to be plus infinity still. Now it's going to be e to the power of plus infinity is plus infinity. So 3 minus plus infinity over 2. So minus times plus is going to be minus. So 3 minus infinity. So it's going to be minus infinity over 2, which is minus infinity. Now we need to find the same thing, but at plus infinity. So limit x going to plus infinity. 3 minus e to the power of minus 2 plus infinity plus 4 over 2. Now minus 2 times plus infinity will be minus infinity, so it's going to be 3 minus e to the power of minus infinity over 2. E to the power of minus infinity is 0, so 3 minus 0 over 2, which is 3 over 2. And this is basically it for this question in differential equations. We're going to jump into this question over here, which is acceleration, and we want to find the position function. So let a of x be x squared plus 2x plus 1 is the acceleration. Find u of x, which is the position. So we need to understand that in order to go from acceleration to position, we need to pass by velocity. So we're going to integrate not once over here, but twice. So integrate and integrate again. So let's start. The integration for x squared plus 2x plus 1 is a very simple integration. It's going to be x cubed over 3 plus 2x squared over 2 plus x plus c. Now, given the initial condition, this, first of all, this is the velocity function because we literally integrated a of x to reach v of x. So this is the velocity function that we have. So obviously we're going to use this initial condition right now, which is v of 1 is equal to 2. So since v of 1 is equal to 2, we're going to replace x with 1. So 1 to the power of 3 over 3 plus 2 times 1 to the power of 2 over 2 plus 1 plus c equals to 2. So this is going to be 1 over 3 plus 1 plus 1 plus c equals 2. 1 plus 1 is going to be 2. Move it to the other side. So 2 minus 2 is going to be 0. So c is going to be equal to negative 1 over 3. Now, so we're going to write the velocity function again. So v of x is going to be equal to x cubed over 3 plus 2x squared over 2. 2x squared over 2. 2 over 2 is basically 1. So I'm just going to write it as x2 plus x plus c. C is basically minus 1 over 3, so I'm going to do that. Now, I'm going to integrate this all over again. So x cubed over 3 plus x squared plus x minus 1 over 3. Never forget your dx. Now, this integration is going to be x4 over. It's supposed to be over 4, but I already have a 3 down, so it's going to be 4 times 3, which is going to be 12, plus x cubed over 3 plus x squared over 2 minus 1 over 3x plus c. This over here is going to be your position function. Now, we use the initial condition of u of 0 is equal to 2. So since u of 0 is equal to 2, so I'm going to replace x with 0. 0 over 12, 0 over 3, 0 over 2, minus 1 over 3 multiplied by 0 plus c. That is going to be equal to 2. So since this is 0, this is 0, this is 0, this is 0, c is going to be equal to 2. So the final answer is going to be u of x equals x4 over 12 plus x3 over 3 plus x2 over 2 minus 1 over 3x plus 2. This is it, guys, for this video. This is actually going to be the final video for a quick revision, and thank you so much for watching.